This video is a tutorial on Chapter 9 of Building Java Programs, which covers inheritance. And I've set up a set of tasks here that we're going to try to go through and exercise the features that Chapter 9 covers. So we're first going to create an employee named John. And in order to do that, we have to create the employee class. And I've laid out here what the specifications are. We have an employee name and salary. So let's go ahead and put those in. We are going to need a private string employee, name, and we're going to need a private double for the salary. Then we're going to have a constructor, and we're going to jump to the getters and setters, and you'll see why. So we're going to have a public, we want the getter for the name, so let's do public return string get name, no parameters. It's going to return this dot name, and then we're going to do a public double get salary, return this dot salary, and let's give it some javadoc /** control enter will give us the ability to gets the employee name, return name. Now when I do that, I'm going to save this file, and then later you'll see that we can actually use that javadoc /** gets the employee salary. Okay, let's do the setters here. It's going to be a void set name of the string, and this will be this dot name equals name public void set salary of double salary, and this dot salary equals salary, and then quickly give okay, we've got that. Now let's go back to the constructors. We've got getters and setters. So we want a constructor that takes all fields. So we know that to make it a constructor, we are not going to have a return type. Instead, it's named the same thing as the class. And we're going to take these two fields here. Double salary. And then now that I've got my setters, I can call this dot set name and this dot set salary, and we're done. And let me just make a javadoc and paste that line in. And then we also want a constructor that takes the name and calls the other constructor. So it's going to be similar. I'm going to copy this here. We'll replace the contents of this though. And now it's just going to take a name. And the salary default is 50,000. So now how do we call the other constructor? So in order to call the other constructor, all you have to do is call this, and that is basically calling the other constructor. So now all we need to do is provide it the name and 50,000. as the salary. We don't need to set the salary because the other one's doing that for us. Then let's see, we got one more thing down here. We need to do the toString. Public string to string, and you got to make sure you get this exactly. And I'm going to return use string.format, and you'll see why. String.format is pretty handy because you can fill in all these fields very simply. I'm going to copy what I want to output. Then I'm going to replace this. That's going to be a string %s, and this is going to be a double %f. And I just have to give my this.get name and this.get salary. And then let's give it a Java doc. And I want you guys to do Java docs for all your functions, and you'll see why that's useful. Let's go up and actually create this thing now. So the type is called employee, and it's colon John equals new employee, and then we are going to use the single parameter John. Now, if I'm not so sure about how to use this, I can now hover over employee. Oh, sorry, I got to save the file first. There we go. If you hover employee, you see the constructor that just takes the name and calls the other constructor with salary default of 50,000. I probably shouldn't have mentioned the other constructor, but salary default 50,000. And similarly, if I wanted to do this dot get, sorry, not this, John dot get name, I can hover over get name, and it gives me the Java doc that I had created earlier. So isn't that nice? So that's John, and then let's test that out. Let's do a sysout of John. Let's run that. Okay, now notice that the double came out really long. That's by default. You can fix that with string.format to just tell it how many decimal points you want. We'll give it 2 decimal points. There we go. So the next task is we're going to make a teacher Jane. And I'm going to go ahead and type this code in first. We're going to create a new class called teacher. And this variable name will be Jane. And it'll be a new teacher with Jane. Now let's go create that class. So teacher is a subclass of employee. So we're going to try to utilize as much of that as we could. So let's start by creating this teacher class. We're not going to put public, but we're going to start with class teacher, and then the syntax for inheritance is you say extends, and then the name of the superclass, employee. So this means that teacher will inherit all the member variables and functions of employee. So everything we just wrote will automatically be available to us here. But there are differences, otherwise we wouldn't have bothered to create a subclass. For one thing, we're going to add a new field here. Sorry, not string, it's an int for class size. So most employees don't teach, and so class size wouldn't matter, but employees are going to have a class size. And then we are going to, now if we didn't do anything, it would run, but the constructor wouldn't know anything about class size. Class size would be undefined. So we do need to set class size in a constructor. So we're going to create another constructor, and again the constructor's name is the same as the class, teacher. And let's review what I did here. So the constructor takes a name. So we're going to do that. We're going to continue using the string name. Now, as I mentioned, we want to use the constructor of employee. So what we can do is use the terminology super and then whatever we pass into these arguments of super, it will go back to the employee class and look for what constructor there is. And I remember I wrote this constructor with just the name, so we're going to try to use that. So we're going to pass in that name, and that will set the name and the salary to 50,000. But you notice that I'm actually wanting the salary to default to half of the employee's salary. So I need to actually manually override this. So I'm going to call the set salary of, I'm going to use the get salary, and then divide that by 2. And the get salary will be valid because super has already been called. Another thing to note is that super is always required to be the first line in a constructor if you're going to use it. And that's exactly for this reason, because if you didn't put it in the first line, then you would end up overwriting it, the values that you're doing. So we're going to set the default salary to half that, and then we need to set the class size. And I haven't written this yet, but let's go ahead and write it. This dot set class size, and this will be 30. And so let's go write that setter. So we're going to do public set class size, and this will be int class size, this dot class size equals class size. And let's do the getter. Turn this dot class size. And I'm not going to put the Java docs in here just to save time, but you do need to put Java docs in yours. All right, so we got the gets and set class size. We need a toString here, so let's copy this. Actually, let's start by copying the overall toString function. Try that again. Start by copying the overall toString, and then we're going to, well, I know that all we have to do is just replace this with teacher. It's going to be name, salary, and then class size equals %d, and I need a this dot get class size. Let me slide these down there. And I need to close this up. That'll fix that red X. Okay, small error here. Return type. Void. And this, okay, that just went away now that I've written the set class size. So we've got the class size defaulting to 30. We're calling our super constructor. We've got the constructor which takes the name. We've got the toString which includes the class size. We need to add a method called grade that takes a fruit. So let's put this in here. Public, and I believe this is just a void. No, well, it says return. So let's make that be a string. Grade takes a string fruit, and especially since this is different, let's make sure we document. Okay, so what does this have to do? This returns, well, we're going to need an if statement. If fruit equals, we can do an ignore case of a plus, then return, oh, sorry, other way around. It's apple. Apple return A plus, else return F. Okay, so we've got that. Let's see if we can run this. So we created teacher Jane. Let's print out Jane next. And run that. Okay, so we've got salary was half of the employees for teachers. Class size is 30, so that's all good. Now let's also, whenever you write code, you got to make sure you test it. So let's try grading. Jane.grade, and let's try pair. And let's also try grading an apple. And we're going to actually have to sys out this. Let's run that. Okay, so the pair gave us an F, but the apple gave us an A+. Excellent. Next, we're going to create an adjunct teacher with Joe. So again, I'm going to go ahead and write the code first. Adjunct teacher of Joe equals new adjunct teacher with the name Joe. And let's go write that class. So similar to how we did teacher extending employee, we are now going to have a function, a class, adjunct teacher extends teacher. So this inherits all the functionality of this teacher, which also inherits all the functionality of the employee. So we can access either one of those. So what do we need to do? We need to create a salary 20% less and a class size of 15, no fields, so that's a little bit different. And we're going to go jump straight into our constructor. So we're going to have public adjunct teacher, and it takes a name. And then we want to construct a teacher. So we can call its immediate superclass, and we'll pass in name. So that will create a teacher with a salary of half of the employee, 25,000, but we need to set the salary 20% less than that. So we're going to do this dot set salary. Let's try this again. Dot set salary, and then this will be the this dot get salary times 0.8, 20% less. And we also want to set the class size. Sorry, this set class size of 15. That's the 15 is the default for this. So that's what our constructor is, and then we need a toString. And this is going to be an adjunct teacher with the same name, salary, class size. All of that still is the same. The only thing is that we just wanted to print adjunct teacher. And that's it. No special functions. So let's see if this runs now. We just need to sys out Joe. And let's run that. Okay, so we've now got an adjunct teacher Joe with salary 20,000. Let's just double check. That's 20% less than the teachers, and the class size was 15. Now the question is, can we grade? Can an adjunct teacher grade? Well, it inherited from teacher, so we hope so. Let's do Joe. And let's try a grape. And it failed as we expected. But if we change it to Apple, it should return an A+. Very good. Now we want to put these three into an array. So let's create an array. So you might ask, well, how do you create an array of three different objects? Because if I wanted to create an array of an int, a double, and a string, I can't do that. But that's the beauty of inheritance, because inheritance lets you treat the superclass as any of its subclasses. Actually, it's either way around. Any of the subclasses can pretend it's the superclass. So we can actually write an array of employees, and we can create John, Jane, and Joe. And then sys out emps. Let's try running that. Actually, we need to do an arrays.toString. I think let's just double check. It's probably not going to be very, we need an arrays.toString of emps. Okay, so there it is. We've got an employee, a teacher, an adjunct teacher. So can you, instead of doing an array of employee, can you do an array of teacher? And already it's saying, no, you cannot convert from employee to teacher. What about adjunct teacher? And what's the error now? You cannot convert employee or teacher to adjunct teacher. That's because only the subclass can pretend that it's a superclass, not the other way around. Let's go back to teacher. So John was an employee, Jane is a teacher, Joe is an adjunct teacher. What happens if I got rid of John? So now I've just got a teacher and an adjunct teacher. That has no complaints. It'll work fine. Okay, so let me go back to where we were with an array. Now, this line of code here, it looks pretty pretty straightforward, nothing significant about it, but it actually is quite significant because this is the first time you are seeing what we call polymorphism, which means that you don't one line of code can actually be used with several different types of objects, and you don't know what code is going to be executed. Let me write this out with what this really is. So let me write this loop. For employee in emps sys out of e. This is the equivalent. It's going to put it on 3 separate lines. And when you run this line here, println of e, I cannot tell you from just looking at this line what code this executes. That's not true for any of these other lines. All these other lines, when it calls println of Joe, I can tell you exactly which line it is. I go down to the adjunct teacher and I look at the toString. Here, when I println Jane, I go down to the teacher code and I look at the toString. Here, I don't know. And it seems very small, but this is the foundation of polymorphism, which we will play with a lot more in homework 1, and you can see the value of it. Another question that is about which item you can store into which. Let's suppose that the compiler was not very smart, and what it would let me do is to create a teacher, let's call it Rex, and we'll create a new employee. Let's suppose it'll let me do that. It won't, because it'll say cannot convert from employee to teacher, because that's a superclass going into a subclass. Why is it not allowed? Well, because if this were correct, what I could do is I could do rex.grade of hello, and this is going to crash. Why is it going to crash? Because this object is not a teacher, it's actually an employee. And so when it goes to look up how to grade, it's going to see that this employee doesn't have a grading function. And so that's why the compiler will not let you do that. So let me get rid of this and let's move on. There is a handy function that Java gives you which lets you figure out what the class of an item really is. So again, in this array here, we get three different objects in this particular instance. I can actually put code in here to figure out, is the object a teacher? And if so, then grade, let's say apple. So how do we figure out whether the object is a teacher? There's a special keyword. It's called instance of, and it's a little bit unusual because it doesn't look like a function. Instead, it uses the syntax if e instance of, and then the name of the class, teacher. And then what I can do is I'm going to try to grade this by saying e.grade. Oh, I was gonna try to do it without it, but it forced it here. Let me show you. Try to unforce it and see what happens. E.grade of apple, and I don't want these outer parens. I just want E.grade of apple. All right, so E.grade of apple will not work. Why? Because it still knows that E is an employee. That's what we told it, and it knows that there's no grading going on in an E. But you can change the object to be E equals, and then force it to be a teacher, E. Actually, we have to create a new object. Teacher, T equals forcing of E into T. And now we can do T.grade, and the error goes away. And this is important because you will need to do this in homework 1. Let's go ahead and run that. Oh, I have to print out sys out. Let's run that. Okay, so here we go. John. It's a little bit confusing as to where the output begins and ends. We've got last three things. There's John here is an employee, and that's all that it prints for John. Then we come in here for Jane, and it actually, here, let's get rid of the print lin, make it a print. Let's put a space afterwards. There we go. This is what that loop there is printing. And you can see that for teacher and adjunct teacher, it's actually printing an A+. But it knows that this instance of teacher is false. Last thing I'm going to show you is abstract classes. So there are some classes in class hierarchies where you never really actually want to create one. Because when I'm hiring people, I never just hire an employee. I hire a teacher, I hire a janitor, I hire an administrator, I hire a secretary. I don't hire employees. So what you can do is use the keyword abstract. And what that does is it prevents anybody from actually creating an instance of this. And so it doesn't change anything in here, but if we go back up here, it now complains because you cannot instantiate a type employee. So in order to make this work here, I actually have to change this. I can no longer have an employee. Let's make employee to teacher. And let's try running that now. So now the last three lines are going to be three teachers. Notice how now we've all got A pluses because these are all teachers. Teacher, and adjunct teacher. So that's an abstract. And again, why do you want to make things abstract? It's so that people don't accidentally create an object that you didn't intend them to create. I never really want somebody to create an employee. Only teachers and subclasses of teachers and other specialized employees. So what you want to do is you want to submit this file, making all these changes that we've done here. And just to review, what did we learn here today? So we learned how to, we first reviewed how to create a class. We did the employee class. You really should be able to do something like the employee class without even thinking about it. All you need is the class name and the class member variables and types, and you should be able to generate a class. Make sure that you use setters in the constructors. Make sure that you use the getters in the toString. I also reviewed how you can use string.format, and that's especially helpful for these two strings. We then reviewed how to subclass a class. You use the extends employee, and you can add new fields. You can use the superclasses constructor by using super. One thing I didn't show you in here is how you can reference another constructor, and you can do that by using this. I don't have another constructor here, but if I did, unfortunately I'd kind of done it the wrong way. But the format for doing that is you say this, that calls another constructor in your same method. And again, it looks up whatever parameters you're passing, and then it'll try to find that constructor. But you know what? I can actually, don't I have two constructors in employee? I do. Look at this. Oh yeah, I already told you how to do that. Okay, great. So we reviewed how you can call this as a constructor, as well as super as a constructor. Super must be the first element in a class, in a constructor, if you're going to call the super constructor. I showed you how you can create a method for a subclass that does not exist in the superclass. And then we did another layer of subclassing, showing you how you can refer again using the super. You can refer to the superclass. But maybe most importantly, what this all was working up to is, what is polymorphism? Polymorphism is when you can look at a line of code like this one, and the question is, do you know what code gets executed for sure? I do, because I know that this is an adjunct teacher, and I can go to the adjunct teacher toString, and I know it's that line. A line of code like this, I don't, because I don't know which object that is. It could be any of, well, it used to be 3, now 2 objects, and so I can't tell you what line of code that is. And there's some good value there that we'll get into in homework 1. I also showed you that you can distinguish which type of object it is in a polymorphic piece of code by using instance of. But when you do that, you do need to actually force the item to whatever instance you're looking for before you handle it like that. And that is about it.